In today's video, I'll be showing you how to make a horizontal fan that pushes you backwards so that it actually resists your forward momentum and you have to work to get through it. Let's see how it's done.
Game Dev Journey.
Welcome back everyone, and today we're following on from our previous video where we made a vertical fan. This time we're going to make a horizontal fan which pushes the player sideways. So we're going to add a new scene, and the fan will be an area 2D. So we'll create that and we'll rename this to horizontal fan. Now we're going to need a collision shape for the area 2D, and we'll make it a rectangle. And we're going to need an animated sprite with sprite frames. We'll rename the first one to off, and we'll go to our fan folder and we'll take the off animation across over there. And we can also, while we're here, add a new animation. We can call it on. We'll go to the sprite sheet. We go to our assets folder, fan. There's the on sheet. There are 4 frames here, but only 1 vertical. And we'll select them all and add them, and there they are. What we should then do is also set the frames to 15, and we'll have looping on, and we'll autoplay this one. This fan will always be spinning, always be on, whereas the vertical one only triggered when the player was above it. This one will always be spinning, always be pushing. Now we need to give some evidence that this fan is spinning and generating airflow to the player. We're going to do that with particles. Now in the vertical fan I used wind lines to indicate it. This time I'm going to use little dots, almost like dust particles blowing in the wind. So we'll go to the horizontal fan and we'll add a new GPU particles 2D node. There it is. We get this error that there's no process material. We'll add that right now. So we'll add a new particle process material, and there you see the particles start falling. So this is going to be permanently emitting because our fan is always on. We'll increase the amount to 16, and we'll go to the particle flags. No trail on this one, that's what creates the lines. We'll go to our process material here and expand it. We'll go to our spawn and expand that, and we'll go and change the velocity here to, we'll set the spread to 10, and we'll set the initial velocity to 100 and the max to 150. And there you can already see we've got a blowing effect. It's just not in the correct direction. So the direction is meant to be -1. Now they're already going up and to the right, so let's change the x direction to 0, and now we've got them going upwards. So what we can do now is expand accelerations here and expand gravity, and we can swap these. We can set the x gravity to 98 and the y gravity to 0. Expand the display property here and expand scale, and we'll set the scale minimum to 1.5 and the max to 1.5 just to get them a little bit bigger. And here we have the effect, but this is a horizontal fan, so what we really want to do with this fan is rotate it. So if we go to the animated sprite, we go to the transform, we want to rotate it 90 degrees. Since we've done that, we don't want the direction to be in the y, we want it to be in the x direction. And because we've set gravity to 98, everything's going to be pulled this way anyway. And so now we've got this fan, and it looks like it's got some dust particles blowing in the wind. And what we can even do is well, we've set on to autoplay, so in the actual scene it will be spinning as well, which is going to make the effect look even better, because if we press play, there you can see the effect we've got. Okay, so we've got the effect that we want. Now let's just sort out the collisions, because similar to the vertical fan, we have to extend this collision, this hitbox, so that we can detect when the player is in it. We're going to extend this hitbox out to the right. Now you can grab it by the handles and do it manually, but I've got a kind of custom range of values that works pretty well. So on the collision shape, if you expand the rectangle, I'm using 180 pixels on the X and 34, 35 on the Y, and for its actual position over here, I've positioned it at 90 on the X, 0 on the Y, or you could even move it up a bit and put it on 1 if you wanted to. I don't think that makes much difference. And I didn't scale up the previous fan, but it might actually look better if we make it a bit bigger. So I'm going to scale it 1.5 times, and we'll see what it looks like once we're in the scene. Now the next thing we have to do is attach a script to the horizontal fan. So if you click on the horizontal fan node, click on attach script. Let's attach the script, put it in our scripts folder, and click open and create. To get a reference to the animated sprite, we hold Control and drag and release. And to get a reference to the GPU particles, we do the same. Now we have a reference to each of those, so we'll be able to set the particles emitting on or off and play the on or off animation. Now, we need a variable to represent the horizontal force that is going to blow the player. And we'll set it as 80, that's to the right to start with, and we need a variable for the player as well. Then we're going to go ahead and connect the body entered signal of the node here. We'll go and connect that. And we'll also connect the body exited signal, so that when the player is in the area of the fan, it will be blown to the right. So we'll check, we'll say if the body dot is in group player, then we will set the player variable to our body. And what you could do here is turn the animated sprite, play the on animation and emit the particles, but ours is set to autoplay and the particles are always emitting, so we don't need to do that. But when we exit when the player exits the fan area, we want to remove the force, the horizontal force from the player. So we should set our player equal to null, so that there's no force, no horizontal force acting on the player anymore. Now, in our process function, so in our function, our physics process function, physics process, that's where we're going to add that horizontal force. So if there is a player, we're going to say player dot push across, and we'll push across by that horizontal force amount. Now this function push across does not exist in the player script, so we're going to have to go and make it. So I'm going to save this horizontal fan scene in my scenes folder, and we're going to go to the player, go to the script. We have our push upward function, and now we will add our function called push across. So we'll say push underscore cross, and it's going to be by the horizontal force. And what we'll do when we call this function, actually let's go velocity in the x direction plus equals horizontal force. Let's test it. Let's see how it looks when we play. Okay, with that done, we should be able to go to our fan level and add a horizontal fan to the level. So let's go find our fan. Here's our horizontal fan. Let's put one up there. We zoom in, that looks perfect. So there we can see it's acting on the player. Let's actually bring it down so it makes it difficult to get across that platform once you're up. And let's test it. So we run the scene. So if we now go up and it's not acting on the player currently there, so we'll have to debug it and see why. So after doing a bit of debugging, I found that if I make the horizontal force large, like 800, and I run the fan level, you'll see that if I don't press left, if I don't override that by pressing left, if I just step into the fan area, I get blown back. But I can easily override it just by pressing left. So we're going to have to make a few changes to our code. I'm going to put this back to 80, but in the player itself, in the script, we're going to have to add another variable here. We're going to have to add a variable at the top here called external force. So I've gone ahead and put it in there, set it to 0.0, and if we wanted to use this for the vertical fan as well, we could. So I'm going to say external force in the x value, and then in our push across, we'll modify push across to use it. So we'll say that instead of velocity x, instead of manipulating that directly, we'll say external force x plus equals our horizontal force. Now, that's still not going to work. We're halfway there. We'll still be able to override it by pressing the run button. So we'll have to go and find our physics process function in here, which is here. Here's physics process. So instead of here where we call run, we're going to have to do a check, I think, in our run function here. So we're going to have to say that if the direction is to the right, then our velocity x is that. Otherwise, velocity x is moved toward that. Now we're going to have to actually replace this. We're going to have to say, let's see how we do this. Okay, we're going to have to do something like this. I'm just going to comment this out for now. We're going to have to say if input underscore velocity, well, we'll create a variable for input velocity. Variable input velocity equals 0.0. And then if the direction is to the right, we'll have our standard here. Well, we'll have this will become input velocity. So we'll copy this, and this will become input velocity x is going to be equal to direction times speed. Otherwise, so we'll grab this here. Otherwise, we'll say that input velocity x equals that. And then we'll say velocity dot x is equal to input velocity plus the external force x. And then we reset external force x. We'll have to reset that each frame. So reset each frame. That should fix it. Let's save it and test. So go back to our fan level, run it. Okay, that little error we were getting is because I said input velocity dot x, which is a mistake. So it should read like this. So our run function has now changed from this simple one there to having an input velocity. If you're moving to the right, everything is the same. If you're moving to the left, everything is the same. But our x velocity is now affected by the external force. And then we reset it. So now if you test the level, when we overlap that fan, we actually get pushed backwards like that. And now we actually have to push against the fan to make it through. And the greater we make this force in the fan, the harder it will be to push against. So let's have a look. So if we go now it's even harder. We can't actually even run against it. And there you go. I hope this was helpful.